Hi everybody, welcome back to Math 2413, more on math. Today we're going to talk about Chapter 2, Section 6, the homework. Here's a note. Limits at positive and negative infinity. Whenever you have a rational expression and the larger x value is on the bottom, as x goes to infinity, positive or negative, then the whole function goes to 0. When x is 1, 1 over 1 is 1. When x is 2, when x is 10. You notice how when the bottom gets bigger, the number gets smaller. Eventually, as 1 over infinity, it gets so small, it's relatively 0. So, that's what we're going to do in this section. We're going to find the limit of this function. So the limit of 9 minus x as x approaches infinity, minus 4. So we could split this up. So we have limit of as x goes to infinity of 9 over x minus the limit as x approaches infinity of 4. This is a constant. So as x goes to infinity, this one goes to 0. This one, no matter what, it stays at 4. So the answer is negative 4. Likewise, going to negative infinity. So we split them up as x goes to negative infinity, 9 over x. As x goes to negative infinity of 4. 9 over x, this one gets awfully big, so this one goes to 0. We're left with negative 4. The next one, now we have the function, the limit of as x goes to infinity of pi minus 23 over x squared. We can split these up again. So the limit of pi minus the limit as x goes to infinity of 23 over x squared. Since bigger x on the bottom, as this goes to infinity, that one goes to 0. Limit of pi remains pi. Similarly, as x goes to negative infinity, we can split them up. 23 over x squared. Again, this x is on the bottom. It goes to 0. This is a constant. This stays a constant. No matter what x becomes, it's always going to remain pi. Here we look at this also. Limit as x approaches infinity, we have separated. Now a fraction. Limit as x approaches infinity of 13x. This one's bounded by +1 and -1 times 17. So this one's bounded. This one, as x goes to infinity, this one goes to infinity. So it goes to 0. Okay, similarly, in algebra, we look at the leading terms, because the leading term, as x gets bigger, it's the leading terms that dictate what happens in the function, so we don't really look at those. What our function really looks like is like this. So the x's cancel, so it remains a constant number, 8 over 7. Same thing with this one. As x goes to negative infinity, it's still 8 over 7. So whenever we have rationals and they don't go to 0 over 0, just cancel out the exponents of leading terms and see what you have left. Find the limit of f of x of that one minus that one. So 8 over thirds bigger than that one. As x goes to infinity, 13 over 5, it's bigger than the rest of those. So we have 4x 8 over 3, x 13 over 5. Since we're dividing, we can subtract the exponents. 8 over 3 minus 13 over 5. Get a common denominator. So this one needs a 5, so it's 40 over 15. This one multiplied by 3 minus 39 over 15 equals 1 over 15. So, since it's a positive number, that means the top value is bigger than the bottom. Since the top is bigger than the bottom, it goes to infinity. Find the limit. As x goes to 0 from the left. This one was supposed to be infinity or 0. Oh well. As x goes to 0 from the left, this goes to 0. 0 goes to goes inside there infinite number of times. So if we had 8 over 2, 2 goes into 8 4 times. 9 over 1, 1 goes into 9 9 times. 2 over 0, it goes in there infinite times, or it's undefined. So as limit goes to x, in other words, this is what we have here is a vertical asymptote. When the bottom goes to 0, our function, it goes negative down, so it goes to infinity. Five to the right. Same thing there. This is what this graph looks like. The basic function here is 1 over x, which is like this. It's shifted to the right 5 units. So as we're coming to the right, it goes to infinity. Now, the reason this one's infinity, that's why you may ask, is the graph looks like this. If we're coming to the left, shouldn't it be negative infinity? Yes, but the numerator is negative. So in essence, this graph is flipped. So as we're coming here, we're going up. Number 8. And here we have again. This one, the graph looks like this. If we're going to there from the right, it's going to positive infinity. If it was from the left, it would be the negative infinity because it's going down. Find the limit. The function itself is 1 over x squared, which looks like the Atari symbol. But this one's shifted to the right 9 units. So it's coming from either left or the right, doesn't matter where. They're both going to be positive infinity. This value here can never be negative because the top power is even. So even if x is negative, we have an asymptote at 0. As it coming from the left, to the 4th power makes it positive. Going from the right makes it positive. So this was going to be infinity also. Alright, that's it for that chapter. Good luck, everybody.